this video we'll be continuing on our 6-part series on Code April. So this is the third part. I will be talking week 3. We'll be attempting week 3 solutions. So if you've missed the week 1 and week 2, I'll put a link somewhere up there. Make sure you go click so you understand where so you just follow through what we've done for week 1 and week 2. So we'll be going for week 3, that's from day 15 to day 21. So the focus for day 15 was Pandas, introduction to Pandas library, Pandas series, data frame basics, and reading and outputting data. I think this is my best part. Like when it comes to Pandas, I think this is closer to start to application, so it begins to make sense from here. So the first question is, what is the difference between a Pandas series and a Pandas data frame? If you've worked with Excel before, tables, data, series is just like working with a single column in a table, while data frame is the entire table. Just take that simple for short. So the second question now is, create a list of 12 integers and convert to Pandas series. So the way we had NumPy series, so you can convert a list to a Pandas series, or a NumPy one-dimensional array to a Pandas series. Okay, so now we have our list. Okay, so it's similar way. So we have integer series. So if we print type, let's see what's the type of this. Let's see type. This would be Pandas series. Option 2, so the same the way we did, remember when we did NumPy, rather than specifying all the items, you could just call a random number to produce series, a random number between 0 and 100, and to give you 12 items in the list. Yes. So the option 3 is just to do this generally. Yeah, so they are the same thing. So the third creates, okay, let me see, create with the following keys. Okay, so they say we should create a dictionary. So the third question is, create a dictionary of 10 items with the following keys. So this is number 3. Yes, let's just do number 3, create a dictionary with 10 items with the following keys. Okay, so we have this blah blah blah. So we have this data, so we have a dictionary. So the first item in the dictionary, so remember, it's key value pair. So the first key is name with all the names, age, and so forth. So now we want to convert the dictionary to a data frame. Just use pd.dataframe to convert that to a data frame. Simple. Then now to output, so you can save all these as so you can save this your data to CSV, just the df to CSV, whatever you've called. If you call it data, whatever the name of your data frame, just do dot to CSV to save it as a CSV, or to save it as text. You can use .csv to save it as text, and specify that your separator is tab separator. You can also save it to JSON file as JSON. So there are different ways to save your data frame. So now we're giving a data set. So if you participated in Code April, you would have received the Pandas, the data frame. Okay, so the diabetes data frame. So let's see. We can read this. So just do put the path to where you have saved the data. So I have it in my folder. So in this my folder structure, I have notebooks and I have data. So I just did this. It just takes it back from this folder, and this enters to data. So that's a different part of Python programming. You can just copy the link to where your CSV is, and you can just import this. So now I've imported this data frame as this. So the next question, number 5, is, you can also read your CSV from a website, a link. You just put your URL and you do the same thing. So it just depends on how you want that to appear. So have the same data. You can read directly from your saved downloaded file, or read from a URL. So day 16 was focused on Pandas function, indexing, slicing, just indexing. So there are different ways to indexing with Pandas. So you have lock, that's you are using, like you're calling using label names, or using filtering, or using conditions. With iLock, you are using the integer itself. So lock, you know the difference. Lock, you are using label-based indexing, or with iLock, you are using the index itself. You see how that goes. So they say load the diabetes data. So the same thing we use for the 15. So this apply to Pandas function. So we do diabetes.head, .tail, .head returns the first 5 items, .tail returns the last 5 items. and you can do .info, just gives you an info about your items, the null values, your data type in each of the columns. Then you can get the top 10, so you can also describe, just describes the numeric column, the count, the mean, standard deviation, things like that. Then to get the first 10 rows, there are different ways to go about it. You can either do .head, so remember the .head, the default is 5, but if you specify a number inside, it shows you, gives you the top, if you put 7, top 7, in this case top 10 rows. So you can either do this, or you could use your iLog to say, okay, remember indexing, you're slicing, so using this, give me everything, all the rows from the first to the 10th row. Yes. Then to get the last 10 rows, so the same thing, either you're using .tail or you're using a negative indexing to get the last 10 rows. Okay, so now take this next question is get the first 5 columns. So using the indexing, so using this column shows give me all the rows, but give me the first 5 columns. So you remember, so you're using iLog this time because we're using the integer based indexing. So select the first 5 rows and the first 3 columns. First 5 rows and the first 3 columns. So yeah, indexing is very easy. When you understand the technique, it's very easy to follow through. So first 5 rows, first 3 columns. So now this is select row at index 2, third row and all columns. Give me the third row and all the columns. Okay, so this would give you all the rows and all the columns. So index 2 shows the third row and all the column. So now you want to also get all the rows where the age is greater than 50. So in this case, we can use either our iLog. It's more like filtering. So we want to filter where age is. So if, for example, if I run only this, it returns all the rows. So it just returns a true false value. So, but if you not enclose it with, so if you enclose this with the diabetes and DF, so it's more like, okay, give me where all this is true. So it now returns all the data where age is greater than 50. So if you go to your age, we only have greater than 50. So this is what we have here. So, or you could also use lock. I remember I told you lock is when you're using label based rather than using integer based, using just the integers. Okay, so using the log, so it returns the same result. So calculate the correlation. So correlation coefficient shows like, okay, when you plot x versus y, what's the correlation coefficient, rather than doing it for all the columns individually. You could just use the dot correlation. It just gives you like a correlation of all the items together. Yeah, so for example, glucose versus pregnancy, so just about zero, highly, it's not really correlatable like that. So it just gives you that, just shows you the correlation. Let's apply anything you've learned that we've not touched about. So you could get the sum. So I want to miss all the columns with the missing values. I want to sum how many missing values do I have. In this case, we don't have any missing values in any of the columns. So I want to say in outcome, how many unique items do I have in outcome? Zeros and ones. So just shows you I have only zeros and one. So there are more things you can do with your pandas data frame, but as we go along, we get to see more of that. So day 17 is data cleaning and transformation with pandas. So we want to start looking at how to clean your data and how to transform your data in pandas. So first of all, you want to read this file. So this is the file we're using. So just use the URL, and it's the MBA data set. So I want to view the head of the data set. So this is it. So I want to display the basic information. So just use info, just gives you, okay, how many rows I have. 458 rows. In my data, how many columns I have? 9 columns. So the name, so it's an object float. So the next question is display summary statistics for numeric columns. So to get the numeric summary statistics, just to describe, gives you the statistics. Then get the unique value for each column. To get the unique value for each column, just print. I just run a for, rather than doing it individually. You could just run a for loop. Say what's the unique values in name column? We have 459 names. Teams, we have 30 teams. We have numbers under the number column. We have 53 items. Under position, we have 5 unique items. So if I want to get the number of missing row in each column, the number of missing row in each of the columns, just do is NA, or you could use is null.sum. Sum just gives you the sum. So in that name, I have 1 missing row, and 1 college, I have 85 missing college. So 85 names, we don't have college associated with them, and in some cases we don't have salary associated with them. Okay, so we want to check what's the data type in each of the columns. So for name, it's object, same object, just use the D type, gives you the type in each of the columns. So now I want to change the age to integer. So the first thing is, because the age contains some missing value, you can just you can convert NA is not a number and is a number, so we can convert that to integer. So the first thing was to just fill with zeros and convert to integers, then replace the zeros to pd.na to still return the missing items you have in your column. Okay, so I'll just be running fast. I don't want to spend too much time on these different things we're working on. Okay, so the question 7 says create a new column, first name and last name, by splitting the name column. So if you look at the name column, so let's see mbadf dot head, let's just use head. You see the name column, the name has so first and last name, so we can just create 2 columns using first last name and just split. So you can, the default splitting is space, so you don't need to specify anything. Number 1, so I just want to do 1 split and expand through because we are creating new columns. So before you run this, if in doubt, just run to see what that would return. So it returns to okay, so that's been split. Let's say if we don't do expand through, it returns a list for you, but in this case, once it has 2 different data frame, and the expand we have, and yeah, so first name, last name, so it's giving it new columns. So they say make the last name uppercase, so last name is uppercase. Then the next thing they say we should drop the name column. So we could just do let's see, mbadf dot drop. So we want to drop the name column axis. So because it's axis 1, want to drop along the column axis. So name has been, okay, I didn't run this. Okay, so if I run this, name has been dropped, but if I run the NBA data frame, let's run the NBA data frame, but I still have my name. It has not been dropped because it didn't apply. So to apply, I can just do in place equals true. So by the time I run this, if I run this again, you see that I no longer have name, I just have my first name and I have my last name. So then remove all the rows where columns is empty. So I want to remove NA. So I don't want to, with NA, for example, so when you want to drop NA, so I want to drop all the rows with missing values. So if I do, for example, let me just replace this. So if I let me take out this NA. So what this does is if it finds NA in any row at all, it just drops that row, even if it's 1. So in this case, I have 364. But that's not what the question asks. Say where all the columns in that row is empty. So for example, if you look at this thing, this last row, everything is empty. So you say I want to drop where everything is empty. That's why I had to use all. If you don't use all, it drops. For example, in this case, we have to college empty. For this two, it's going to drop all this row, but that's not what I want to achieve. So that's why I use all. So it takes out only where all the rows are empty. Okay, so then say remove duplicate row. So if you have duplicate entries, you could say duplicate NBA. So this just shows I want to see how many duplicates I have. So if you do the NBA.duplicated.sum, you print out total of all the duplicates you have. Then you do drop duplicates, removes all the duplicates. But if you want to drop duplicate based on a specific column, so you could say drop, for example, I want to drop duplicates of, let's say, last name, where you have last name. Do I have any? I think I had some duplicate last names. So but so if you just put that, but in this case I just want to drop all duplicate entry because I could have duplicate last name, but maybe their first names are not duplicate. But it just shows you how to draw if you want to remove duplicates based on certain columns. Okay, so now I want to check how many unique colleges do I have in my data. So I'll just do college.unique. So I have about 118 colleges in my data. how many teams are in the data. So I want to just check how many teams. So I want to get how many unique teams. So we have 30 unique teams. Okay. How would you address the missing data and explain the reason? So there are different ways to address missing data, just depending on the data you're working on, how you're working with the data. So you say MBA. So you want, first of all, I want to check how many missing data do I have. So under the salary column, I have 11 missing rows and college 84. So it depends on how some people want to drop, depends on the approach you're working with. So you can fill with different things. But in this case, I'm just going to leave it. I'm not going to fill the missing value with anything. So now the next question says set the last name and position as index. So I want to make the last name. So just do set index. Use your last name and your position as your index. So this is just do your df dot, that's your data frame dot index. In this case, my data frame is MBA data frame, and that will give you that. So in this case, say what is the maximum and minimum and average of the age and salary. So I can easily say, rather than doing this, for example, I can call this, let's see, so I have age. Let me do this. So I have my age dot max. So I want to calculate the max. So the max age, highest age I have is 40. I can just do the same thing for minimum, but this is going to be a lot repeating this for all the columns I need to run. So I just had to write a for loop to say, okay, for age and salary, print out the maximum age. So this just return. So these are some ways to optimize your code rather than trying to repeat the same thing over and over again. So my maximum age is 40, minimum age is 19. The average of the ages are 26.9, that's about 27 years. And the minimum salary is, let's see, 25,000 USD. And the minimum salary is about 30. And that's 30,000. And yeah, that's just the average. So you can just calculate that. So we say, assuming the height is in feet, that's feet and inches, create a new column called height in centimeters and calculate the BMI of each player. So first of all, what is BMI? Body mass index. So you want to understand what that, you can just go browse. How do you calculate what's the body mass index? And it has a formula. So, but before we go there, we have to convert the column, because for example, let's look at MBA. We're using the new MBA data frame. So we'll create a copy. So we want to start applying some transformation. It's good to also keep a copy of your initial so that it doesn't affect the next one. You just say MBA dot let's see, height dot D type. So let me see, what's the data type in what's my data type? Okay, I didn't run this. Okay. So it should be height in capital letter. Okay. So the data type is string, but I don't want it as in string. I want to convert. So let's say what does the height look like? So the height is 6'2". That's the first is feet and this is inches. So first of all, we want to split using this delimiter. That's the hyphen. So I create my height in feet and height in inches. Okay. So I've split it to feet and to inches, right? Then I cannot convert the height, that's the feet, into meter or to meter, and the height that's the feet to meters, and the inch to meters also. So I just add both of them. So you can do them separately, but I just chose to do them together. So it's more like calculating this. So I want to convert this so take this out. So I want to convert this first of all to meters, and also then I can convert the inches to meters also, then add them together. Okay, so if I run this, so I have my heights in inches, so this is the meters for all the players. So I've been converted that to meters. Then I said, okay, now let me convert the weight. So the weight was in pounds, but I want to convert it to kg, because to calculate for your BMI, you could just go browse how to calculate BMI so the unit has to be in meters and in kilograms for the calculation we want to use to work. So it's just more like converting your weight in your normal weight to weight in kg, and this is what we have. Okay, so now let's calculate the BMI. So the BMI is your weight in kg divided by your height in meters squared. So weight in kg divided by height in meter squared. And when you run this, it gives you the calculation. So you have the BMI for this for all the players, body mass index for all the players. So rather than doing everything in, like we've done it in different steps, you can just do everything at once rather than having them as different steps. So you don't have to create multiple columns that you don't need. So let me just see. So rather than having that, I can do this equals to MBA df dot copy. So I want to just copy back the initial one, so that I don't have all these other columns. So in this case, by the time I run this, okay, height in feet. So I need to calculate this height in feet again. So I need to do this, run this one. So let me just copy this back. Okay, so if I run them, just run this again. So just to calculate my height in feet, and I can calculate this everything in one place. So I don't have the height in meters, so I just have it as BMI, where I've just calculated everything together. So I think a lot of people struggled with this part of the code, but yeah, it's just straightforward. Or if you want to work in centimeter, it works the same way. So let's move to day 18. We're almost getting there. Day 18. So what's the difference between merge, join, and concatenate in pandas? This is, so you can read up, but just know that merge, join, and concat are ways to join different data frames together. There are different ways to do this. Merge, combine. So if you go through this website, let's see. So if you go to the official documentation, you can you can understand what the different merge and join does. So I wouldn't spend time going through. You could just read this up. Again, the notebook will be in my GitHub, and the link to the notebook will be in the description. So you can just go follow the link and just understand what the different concatenated, different method of joining do. So yeah, so inner join returns only the rows, only the intersection. If you remember when we did set what's common between both of them. Outer join just returns everything. And so given this list, so we're given this list. So what was the question? The 3A says create 3 data frames, df1, 2, and 3 with salary. So I want to create, so I have 3 data frame using that. I have my df2 and I have my df3. Okay, so df1 and 2 has the same column names, and this has slightly different column names, right? So say concatenate df1 along the rows. Okay, so let's see what would this return along rows. So it's like more like adding it, so we have more rows. Then concatenate df1 and 3 along axis. So that's along axis 1. So this one we didn't put axis 0 because that's the default. So in this case df1 and 3, so we are expanding the distance. So we're adding salary, and is doing that using the indexing. So the index has to be uniform for you to join that. So now they have combined df1, 2, 3 together. So you can do this using the different methods, but in this case I use join, merge, and I use join together. So it's quite, so df1, df2, it adds because they are the same, so it just kind of extends that. Then join, so I want to join these together. I can now do, let's see, why did I use join here? I don't have no reason. So then you join df3 because of the columns. So the columns, the index for df3 is just from 0 to 4. In this case, because it has only from 0 to 4, so the others will just be filled as, because I use outer, the others will be none. In this case, I want to concat. So in this case, it's just adding. So where you have missing values, just kind of add them along the axis. So if let me try axis 1. So in this case, because I added along axis, so it just repeated, okay, names, because I did axis 1, so it just expanded this one. I have to name each column in this, but I don't think this is the ideal way to go about this. Okay, so you just understand how you join different things together. So there are different ways. You can also merge and join. It just depends, whatever rocks your boat. There's the out left, out inner. So yeah, I think that's a lot. You can just go read up to understand that better. The next question is create a series with names from df1 and concatenate with df3. what was our DF1? So I don't know what I was thinking when I was creating these questions, but let's see. DF1, at least I want to call, okay, we have our DF3 without names. Okay, let's try. So I just want to concatenate. So I created a series, so I want to add these names to this DF3. So this is all. Okay, so if you just do this concatenate, so it concatenate just adds along the, it stacks it, if you, that makes sense. But this is not what I was trying to achieve. I want it to be on the same row. So you can do this, or I can, either you do this or you can do this. Let's say axis equals to 1. That gives you this, or you could just do name series. So there are different ways with Python. There are different ways to go about the same thing. It just depends on whatever rocks your boat, whatever you feel comfortable with, or whatever you know. So merge one based on the name column. Okay, I think that's enough for that. So let's go on to day 19. Day 19 is focus is grouping, aggregating, reshaping, melting. So there's a lot of aggregation you can do with Python. So we attempt to do that. So we have the first question: what's the difference between pivot and pivot tables? You could just read up, but you know that with pivots, with normal pivot, you can't have duplicate indexes, but with pivot tables, you can have duplicate indexes. But you can read up. You see the syntax to create them, but let's move on. So what's the difference between a wide and a long table? So as you can see, a wide table where you have each variable, it's in different. So this is like a data frame of temperatures in New York and Los Angeles. So you can see for the different dates, you see the different temperature. That's a wide table. If you want to convert this to a long table where you have, let's say you have your date, city temperature, so it shows you, okay, for New York on this day, this is the temperature. So if you have, for example, you have multiple cities, rather than having a very long table, you could just have them white. So it just depends on applications, whatever, how you, for data analysis, you want to work with long tables as compared to wide tables. But yeah, but just understand the difference between your long table and your wide table. Okay, so what pandas function can you use to change from a wide to a long? So if you want to change from a wide to a long table, you're using the melt function. If you want to change from a long to a wide table, you're using the pivot or the pivot table to change. So know the difference and know when to use them. So then let's go to more applications. So they say you're a manager of a store outlet in your city with 5 sales representatives. So you have 5 representatives in your store as a manager. So now I want to create an inventory of data frame for the first quarter of 2024. So the first quarter will be January, February, March. So so now I want to create a table with column name, sex, the product, the total sales number, and the total cost. So instead of writing, so we have 5, for example, let's say we have 5 people and we have 3 months. So instead of trying to write like for example name, trying to write all the names for all the columns and all the months, you could just use numpy to say, okay, for example, name. So I have so they have 5 people, so multiply. I want to have, like, because I have 5 products, for example, so 5 times 5 is 25, and I have it for 3 months, so 25 times 3 will have 75. So I want to get a data frame with 75 rows. I want to get a data frame with 75 rows, as the case may be. So just rather than do, I just do times 15. So that's 5 times 5 times 15 will give me 75, right? Then sex, the same thing. So but I have choice, so it's just more like randomly creating a dummy table or dummy data set. So for random choice, so remember we did random choice, so I want A, B, C, D, 5 products, but I want it in size 75, that's 75 rows. And the same thing month, so because I'm working from January, February, March, I just want random from 1 to 4, that's range, right? But also 75, I just want, so all the sizes are 75 because I want 75 rows. So just this different numbers. So for the total sales number, I just want between 10 and 100. And for the costs, for total cost, I want between 50,000 to 200,000. So doing this, I've generated a random, let's say I have this random table or data inventory for for my shop or for my store. So the first question is, okay, convert. I want to convert the month to date time. So there is the date time thing. So I want to add. So what do I want to do? First of all, since I have my months, I have the month and the date. So I want the first, so it's more like the first day of every month. So this would be, I'm adding so just having the month in this one. So I have my month. Let's say the first month is February. So 1st of February 2024. So that's what that is. But I want to just convert that to date time format. And so when if I run this, so I also want to sort. So I want to start from the smallest down to the largest. Okay. Then the next thing is sales inventory. So I just thought about it now. So you can also have, so the way we have the random sales months, I gotta have days also random. So let me just do that also. Let me generate so let's say from 1 to 20, let's say 28. I don't want to, because of February has 28 months, I don't want to complicate things together. So let me say day. Let's make this day instead. So if I run this, I have my month and day. Okay, that's fine. So now I want to add, okay, months. So this would be my day. Okay, and this would be day. And I want this to be, so this is no longer going to be, this will not be applicable anymore. Then I do plus. So that I don't just have only the first day of the month. Okay, so I think I know what. So it's more like adding. So I'm going to add a plus. Okay, so it's just to add the slashes also. Okay, so I think that's it. So I have my date time. Okay, that's fine. Okay, so I just want to replace the months just to map that. You don't have to do it again. So now let's get all this. So now let's start doing an analysis as the manager of the store. What's the total sales I have in the month, in the first quarter? So if I run this, so I have about 9.4 million. Let's say 4 million pounds, whatever the case may be. Calculate the cost of each product. So I want to say, what's the cost of each of the products? So I'll say cost per product. So it's just more like rounding it up to 2. So for example, for this product, Charlie sold let's say product B, for example. This is the total sale cost and this is the number. So you just divided the total sale cost by the total sale number to get how much per product. Okay, that gives you that. So now they say, okay, get the average sale for each of the reps. So I want to get what's the average sale for each of my rep. So it's more like I'll use the group by aggregation method. So again, the resources I will send contain information about how to study what all this thing means. So if you participated in Code April, the resources we sent along would have explained what all these different methods and function does. So this class or this video is not aimed to teach you how to use all these or what they mean. It's just me providing my own solutions to Code April. Okay, so to get the average sale for each product, for each sale, I want to know how many in the first quarter, how much, or what was the total sale cost for each person in the average cost. So Alice, let's say, will add the highest sale. I think John add the highest sale. So we viewed this. Let's visualize it based on, rather than just, it's difficult to start reading numbers. So the data analysis, you want to visualize, right? So first of all, I want to plot this. I want to see what does this look like. What's the mean sale? So by this, you could just say, okay, let me see. John had the highest sale. So you see he has the highest bar, followed by Bob, Ali. So with this, you're already saying who is performing better and what is performing better. So the next thing, I want to get the total sales of everybody. So this was average sale. So by using the group by using the mean, in this case, I want to check the total costs. Who sold the most? Again, John sold the most in this case, had over 2 million sales revenue. Okay, so now I want to also see which products so I had the highest sales. Let's see. Okay, so product A, we have highest sale for product A. Okay, Now let's get the average sale for each month. So I want to see for each of the months which for which month. So for example, somebody can sell better in month 1 or 2. I want to see which month each person's sales per month. Again, this is kind of confusing to look at, but let's plot this as bar, so you can use your stack bar to plot this. So let's see. This is quite, so for the first month, let's say for February, for February now, Bob has the highest sale for February, followed by John, followed by Alice and John. But in January, also the highest, Alice and John had the highest sale for January, but Bob had the highest sale for February. Then for March, Ima had the highest sale for, okay, this is the mean, like the average highest sale. We can also do the same thing. Let's get us. So for this, let's get the total sales. Let's not use the mean. Let's use the total sales. Who sold more than, okay, let's see. Okay, for January, okay, for February, let's start with February. February, John had the highest total sale for February. Emma had the highest sale for January, and Bob had the highest sale for March. Total sales, not average sales this time. Okay, so average sales for each rep per month. So which rep for each product. So I want to see for each of which of them sold the best, like which product. So with this, you can start seeing which person is selling which product favors which person is the most, whatever that means. So for Alice performed very well with product A. So Alice sells more, like had the highest sales for product A. Bob highest sale was for product C. Charlie's highest sale was for product D. Ima's highest sale was for product A. So Ima and Alice are doing very well with product A. And for John does very well with product E. So with this, you're already seeing who is performing better, where they are performing better. So with this, you can now start making decisions as the store manager. So now say calculate total sales for each person in the quarter. Total sales, so I think it's something we've done initially. So total sale, okay, I think we've done something like this. So generally, John had the highest sale for the quarter. Okay, so now let's start reshaping the table. So let's see. So initially, let's see what was our sales inventory. So this was sales inventory. So we want to see how the product total sale cost. So rather than having it as this, want to have it as a white table. So for example, what we need is the name and the total sales for each of the products. So rather than having it as a long table, we want to convert this to a white table. So that's where we have our pivot table, and so just call the value. So this is the values I want to get. The name and the column's name should be the product. So in this case, I want to get the mean. So the aggregation function is the mean. You can get the function as sum, but it's just the average. Then also you could get the sum. So this is the same thing I said. So you could get the sum of all the products for this. Okay, so I want to reshape using melt. So let me see what does this do. So I want to just reshape this using, so I just want to pick out, so from the table I had initially, let's see from the table, so you just see what the different so I want to reshape the table. So in this case, I want to just get the name, the sex, the product, the variable. So I want to get the total sales number and the total sales cost. So it's more like using the melt to get a long table from a white table. You know, the total sales was a column, total cost was a column, and I want to make it a long table, whatever that means. So you see, this gives you this. That's how to use your melt and your pivot table. So now I perform aggregation using pivot or pivot table and calculate the mean sales by product. So in this case, I want the index to be product. I know we did something like that, but we used the name. But in this case, I want the products to be my my column. So for product A, this is the total sale. So using pivot table, we can get that. In this case, you can want to get the product with the highest sales for the quarter. So just to get to, again, if you don't understand what something does, just kind of break it down. So this first part gives you the sum of all of them. So but I want to get the ID, the max ID. The max ID is product D. So product D had the highest total sales for that month. Okay, based on the action, what would you take going forward? So there are different things you can do as the manager of the store. For example, in this case, we had product D has the highest growth, so you want to focus more on product D. Also, let's say there's a chart we did initially that shows in the different individuals with the product they sell more. So you want to focus on, okay, where some of the strengths. For example, you could say Alex, for the coming quarter, you want to focus on product A. Alice, let's say Alice and Emma, since they sold more of product A, you want to maybe encourage them to do that more and just focus. So these are some of the decisions you can now start taking as the manager of the store. So this data is already showing you the products you are doing best at, the person or the customer rep that is doing the most. So those are some things you want to start focus on. You want to say, okay, for example, Charlie is not really doing a lot. You want to understand why is Charlie for example, if you have a target, for example, Charlie is not meeting his target. It's okay, why is Charlie not meeting his target? Does he have other issues he's going through? Is it that the market is not favorable? So just like some questions you want to start asking. Do you want to withdraw Charlie? Want to focus? So this kind of things you start looking at the product, the persons, and what they do best at. So those are some of the information you can get using your data. Okay, so day 20. I think this is the part where a lot of the people, I don't think any participants submitted this. No, time series data can be really complex, and I don't fault you at all for not being able to attempt this. But yeah, it's one of those things that you should just know about. Yeah, but when you get to, the more you work with these things, the more you get used to it. So this is time series data. So let's start carrying out time series analysis. Okay. So now let's see, we have, let's read this data. So you downloaded this data from this site. So we have our date, mean temperature, humidity, temperature. So now I want to convert our date to date type and make it the index. So since we have our date, but so if we do let's do the df.info. Let's see, df.info. So it shows our date is object, but we want that to be date time. So we have to convert that to date time. So let me split this, for example, and let's run. After running this, so I want to convert our date to date time. So if you see it now, our date has now been in date time, and so this is, so now we're setting the index to be the date. Okay, so now they say resample the data to monthly frequency and calculate the mean. So we want to resample, so rather than, so we have it, so this is date, so we have it at, like example, the 1st of February, 1st of January, 2nd of February, but I want to get the mean of all the months. So rather than having it the data as daily data, I want to just get an average using the mean. So what this would do is, if you find out that the data frame has reduced, also you see that you just have one for January, February, just one half column for each of the days. You can choose to resample based on day. So that's what we have, day. What else can we sample? Let's see, let's sample based on year. So it just sums all the years. So we have 1, 2, 3, 4, 5 years in the data. So those are, so just resampling, just more like summing up, getting an average. So you can do some mean different depending on the aggregation function you want to use. Then calculating rolling mean. Rolling in time series means calculating involves a series of statistics over a particular window. So I want to just calculate the mean of within every 7 days rather than, so it's kind of similar to what we did using resampling, but in this case we just want to calculate within a window of 7 days. So if you roll this rolling sum, so it's just like sum for every for the 7 days. Okay. So you can have rolling mean, rolling sum. So in this case I just calculated, but in this case I want the rolling mean and the rolling sum to be a column in my data. So okay, that's that. So now I want to perform time series analysis with moving average. So this is the moving average. Just get the average based on every 30 days as average of the individual month. Then also calculate the change. I want to calculate the change in temperature for every day. So for example, it's more like this minus this, so it's more like this. minus this, or this minus, so because of we don't have anything before this particular, we have NA, but in this case will be the previous day minus the present day. So that's what the temperature change, the percentage change means. So you just want to get it, what's the change, daily change in this. So you can now plot. So with time series, you want to see what's the difference in the temperature, where am I having high temperature. So it's fluctuating, going up and down. So in some cases you have negative, in some cases you have positive. It just shows you the change in temperature over time. So you could also use your fill NA to fill missing value. So for example, where you have missing value, so let's do df dot is NA dot sum. Let's see, where do we have missing value? So rolling mean we have some missing value. So I can just do forward fill like you're filling the next one with the previous forward fill, and you can do backward fill, whatever that means. Yeah. Okay. So in the next question is, we want to generate dates for okay, in this case we didn't do this, didn't fill because we only did forward fill. But if I want to make do this as backward fill also, let me just, if I do backward fill, B fill, backward fill, so I'm putting DF, so it just fills backwards. Okay, so it just fills that backwards. Okay, now so I want to generate, so for example I want to generate random, so there are some days that might be missing, so I want to generate random days between to fill in, so it's more like PD dot. So I want to create new index. Remember my index is my date, so I want to create date from 2024. So I want to create start date from 2024, 1st of January to 31st of December 2024. But I don't have that in my data frame. So I can say, okay, let's see, because of I don't have any of these dates within my data frame, everything is miss NA. But if I say, okay, let me start from, let's say 2016, let me make this my start date. So I want to just generate random dates and fill, so frequency days. So I want to generate data for all the dates. So I can say, okay, yeah, so I have from 2016, but in this other case I don't have for 2024, so everything now is missing NA. Yeah, I think that's it's not so difficult. Just understanding the different how to work with time series data. I feel like it's straightforward. Thank you so much for watching till now. If you've missed out, like if you know that time series can be confusing, but don't let that come. Just understand, take them bit by bit, and you get to understand the more you do. Remember, the link to this notebook will be in the description, so you can always go download, so you study more and at least follow through as I'm going through. If you have questions, also put them in the comment section. If you participated in Code April and you made it through to week 3, how would you compare my solutions to your solutions? Remember, this is not the ultimate solution. This is how I will solve it. There are other ways that a lot of you have attempted to solve this. It doesn't make it wrong. There are many ways to do the same thing with Python. So bye, see you on the next one. So this is 3/6